Lesson 5.1 Part B. Now I'm going to discuss in more detail all the different types of samplings and good and bad parts of them, but I've already discussed this earlier on, so you can mute me or go ahead and listen to what I have to say. But we're going to kind of go over this again to make sure you understand pros and cons of certain types of sampling. So convenient sampling. Why is this considered bad? Well, it's considered man on the street type of survey. It's cheap, convenient, often quite opinionated or emotional, not very popular with TV. Now it's very popular with TV journalism. So you ask a person on the street, again, not a very good way of getting information. Ask about gun control or legalizing marijuana on the street in Berkeley, California, and in some small town in Idaho, and you're going to get totally different results. So again, not very accurate because not everyone's being asked or having the chance to be asked. Even within an area, answers could probably differ. If you did the survey outside of high school or outside a country western bar, like in terms of Rochester or different parts of Rochester, you're going to get totally different answers. So not very good. And it's opinions limited to individuals who are present when you're walking around. Voluntary response, very common on the internet and by phone. Why is this bad? Well, they choose to be involved. These samples are very susceptible to being biased because different people are motivated to respond or not. They are often called public opinion polls, and if you haven't, and you're probably hearing that quite a bit when it comes to election times, and are not considered valid or scientific, yet they are used all the time. An interesting example here is that Ann Landers, who used to do a lot of very popular column in the paper, summarizing responses of readers. 70% of 10,000 parents that responded wrote in to say that having kids was not worth it. If they had to do it over again, they wouldn't. Now 70%, that's pretty intense. That's not a very good sign. Yet that's a voluntary response. Now most letters to newspapers are written by disgruntled people. Okay, so if they were to take actually a random sample, in this case there was one taken, shows 91% of parents would have kids again. So she asked the question and 10,000 people wrote in, but they wrote in because they were angry with their kids. So the people that were okay with their kids didn't even respond to that question. So voluntary response is very dangerous, and again are actually used quite a bit. And here's some examples of online surveys that you may have already done in the past, or if you look on news sites, this is something that you see quite a bit of. People have to care enough about an issue to even reply. Okay, so again, it's voluntary response. And on the bottom of this survey, so here's the question: is the expense of trying to rescue a dog aboard an abandoned ship near Hawaii justified? So current events, something that had happened in the past, they click yes or no. And here's the answer that they got. 59% said yes, 41% said no. Quite a few people voted too. Over 220,000 people voted. Alright, but they know that this is a voluntary response. So they put this little disclaimer on the bottom that says, this quick vote is not scientific and reflects the opinions of only those internet users who have chosen to participate. Okay, so the results cannot be assumed to represent the opinions of internet users in general, nor the public as a whole. Yet people look at that and say, oh really, that's what people think? And they don't understand that really it's not a good survey. What are some good sampling techniques? Well again, random is the key. Random sampling. If everyone has a chance of being picked, then it's a good sample. Alright, so why are these considered good? Random samples. Because individuals are randomly selected. No one group should be overrepresented. It's possible, but the randomness usually takes care of that. Random sampling gets rid of bias, which we said is bad because it means one group is overrepresented or underrepresented. And random samples rely on the absolute objectivity of random numbers. Now, if I asked you to give me a random set of numbers, you would give me a set of numbers that are not random because you would try and spread them out a little bit. You'd be aware of what numbers you're having. So that actually isn't random. A calculator is the best way to have random results. That's one way, I should say, not the way. But again, you take away the emotional part of picking numbers. Simple random samples. Okay, why are they considered good? The simple random sample is made of randomly selected individuals, and how you get to be random we'll talk about later too. Each individual in the population has the same probability of being in the sample. When I say being in the sample, it means being asked the question. Okay, they got asked. All possible sample sizes n have the same chance of being drawn. Okay, so if I were to pick 5 people, everyone has a chance of being picked. So that covers the idea that you can get any possible 5 groups of people. How to choose a simple random sample of size n from a population of size n. Now the little n means sample, that's the sample, and the capital N means the population. So if there's 1,000 people and you ask 10, then the little n is 10 people and the size n is 1,000 people. Okay. Alright, label, give each number of the population a numerical value. Now, the typical way of doing a simple random sample that you've seen a lot of is I would put your names in a hat in a class and I'd draw from that. Everyone has a chance of being picked. I could also give every one of the students in class a number. Okay, giving them a number. And then draw that number from the hat. Okay, or have my calculator pick out a number. Alright, so we're just giving a person a number. Alright, so if I were to use my calculator, and I'll get that set up here. Alright, I have my calculator up and running here. Alright, so we need to select a random sample of 5 from a class of 20. Alright, now I have my steps written down here for a TI. You can do this on smaller calculators as well, but this is the example I'll give. In other words, we're going to, I pick math, I arrow over till I see probability, PRB, and I want to go down to randint. I don't want random because that's going to give me decimals, and I don't want decimals. Randint means random integers. So I go enter, and my first number tells me what my first number is possible. So if I have 20 students, I've given them numbers 1 through 20. So I comma and I write down or type in 20 because that means it goes up to 20. So random numbers, random integers, 1 to 20. And if I just enter here, I'll get one number. And if I do it again, it'll give me another number. So I go enter, enter. I can get my numbers like this, or I can do a comma and say I want 5. 5 at a time. I can do 2 at a time, 10 at a time, whatever. And there's my 5 numbers. Now if we're going to pick 5 people, make sure there's no repeats. Okay? Otherwise, because you can't ask the same person the same question. Okay? We want new people. So if we have a repeater in here, we just enter again until we get new ones. So for example, up here we had 19, 19, 3. I'm not going to ask the 19 student twice. I would skip that second 19 and go to the next person until I had 5 people. And that's how you can use technology. Pretty convenient. Alright, stratified random. We talked about creating strata to make sure certain groups are represented. This is important because if you consider males and females answering a question differently, then you want to make sure each is represented. For example, like we talked about with student council, if we want information from each grade, then we want to make sure we pick people from each grade. So we want to narrow down the randomness a little bit. We're going to be random, but random within each group. So a stratified random sample is essentially a series of simple random samples performed on subgroups. Subgroups being 9th, 10th, 11th grade, and 12th grade that I just mentioned. The subgroups are chosen to contain all the individuals with a certain characteristic. Okay, so how do we create one? Divide the population of college students into males and females. That's one example of making a strata. Okay. Divide the population of California by major ethnic groups. Okay, so you want each ethnic group represented in the survey. You don't want to ignore anybody. Alright, it's kind of a safeguard, in other words. So major ethnic groups, and divide the counties in America as either urban or rural. And then you would then make sure you have each group be asked the question. The SRS taken within each group in a stratified random sample don't need to be the same size. So in the past you've seen me say up here in the typing 5 of each group. You could have 10 of one group, 100 of another. Doesn't matter. You think it might, but actually it doesn't affect it too badly. Alright, a caution about sampling surveys. Alright, so non-response, response bias, and wording effects. Very important here. You have to be very careful about non-response. Okay, people who feel they have something to hide or won't or don't like their privacy being invaded, probably won't answer. So you have a possibility there. Okay, so let's say you send out a survey to 1,000 people and only 100 respond back. That suffers from non-response. Not a good survey. You want to get as many people answering the question as possible. Response bias. Well, if you ask a question out loud, they might not answer truthfully. Okay, so if you say, how much do you drink? They might feel embarrassed if they were to answer honestly, so they would give you a lie. So when you ask questions in person, you could suffer from response bias. And then wording effects, very important here. The way you word a question can affect how the person answers. So questions worded like, do you agree that it is awful to? Well, you're kind of implying that it's awful. So you're kind of getting them to answer the question in a certain way. Not good sample practice. So wording does affect the response and does create bias. Undercoverage. Undercoverage occurs when part of the population are left out of the process. Okay? And that is important. Okay? So this is a reason why the U.S. Census, every 10 years, very expensive, that's why it's every 10 years, goes house to house. Okay? But even then, homeless people are not represented. Illegal immigrants also avoid being counted. So you have this problem of undercoverage. Geographical districts with a lot of undercoverage tend to be poor ones. Representatives from rich areas typically strongly oppose statistical adjustments of the census because they don't have a problem. But we have to be careful and make sure that we try to get to everybody. And again, that's why the census is only done every 10 years. And they work very hard at getting everyone asked. To assess the opinions of students at The Ohio State University regarding campus safety, a reporter interviews 15 students he meets walking on the campus late at night who are willing to give their opinions. What is the sample here? All right, now again, sample is who he actually asks. Okay? So all those students walking on campus late at night, all students at universities with safety issues, the 15 students interviewed, or all students approached by the reporter. Now remember, a sample is people he asks and gives him information. So that would be C. All right. The population is the whole campus. An SRS, or simple random sample, of 1,200 Americans is selected and asked, in light of the huge national deficit, should the government at this time spend additional money to establish a national system of health insurance? 39% of those responded yes. Now, there's a problem with this. Notice the wording. Huge national deficit. Huge implies something. It makes the responder respond in a certain way. Okay, so this influences the response, and that makes it bad. Okay, so let's take a look at the next page and we'll go on further. The sampling process is sound, but the wording is biased. So the results probably understate the percentage of people who do favor a system of the national health insurance. Understate meaning, because of the way they said it, huge national deficit, they're going to make someone say, oh, of course not, we don't want to do that. So they worded it poorly, so it made people answer against national health insurance. Not that I'm for or against it, but the wording of it caused the responders to probably understate whether or not they wanted it or wanted the national health insurance to happen. All right, should you trust the results of the first survey or of the second? Why? You can't trust the results of a sample survey until you have read the exact questions asked. The amount of non-response and the date of the survey are also important. Okay, so how can we use the data that we get? All right. All right, so let's finish up with why we get the data, for what purpose, and how do we use it. So at a preview of a movie, 6 people out of 500 walk out. Suppose 600,000 people see the movie. Estimate the number of people who walk out. So at this one site, you notice that 6 people walked out. Not a survey, but an observation. Again, data collected, but not a survey, but what does it tell us? Well, if we say 6 out of 500 walk out, we can make a proportion and say how many out of 600,000 then? And the answer for that if you take cross multiply here and take 6 times 600,000 and divide it by 500, then you would get, and we've done proportions before, so this is not new, then you'd get about 7,200. Okay. Another one, in a 120 seat section of a baseball park, 38 people bought programs. Okay, again, an observation, but again, it's a sample. The park holds 54,000 people. Now this is a section, so it's almost like a cluster if you consider that. Alright, estimate the total number of programs sold. Well, 38 out of 125 seats bought programs. So you want to find out how many out of then 54,000 bought the program. And if you again multiply 38 times 5,400, then divide by 125, you get about 16,416. Last example, in part of a shoreline reserve there are 45 nesting adult sanderlings and 17 sanderling chicks. So again, pay attention, 45 adult and 17 chicks. There are 120 adult sanderlings on the reserve. Estimate the total number of sanderling chicks. Alright, so again we have 45 adults, 17 chicks. So if we are wondering about how many chicks there are, how many sanderling chicks there are, we'll make the fraction 17 out of 45, or 17 compared to 45, not out of. 17 chicks to 45 adults. That's alright. And we know that there are 120 adults on the reserve. We want to find out how many chicks there are. So this is a proportion. Again, we would cross multiply. We multiply those two together and then divide by 45. We'll get approximately 45 chicks. It's 45.3, but again, we don't want decimals of chicks. That's messy. And this ends lesson 5.1.